guys, so welcome to Video Notes. This is the way it works. I don't actually put myself unless I feel like I need to. I just thought I would do an intro since this is the first time you're doing Video Notes. This is how it works. I will be doing these where you hear my voice and I'll be writing the notes, and then your job is to take notes, take a picture of them, and submit them before class. Okay? So that being said, what I typically do is I take the 10 topics and I look to see which ones are the ones that I really need to go over. Sometimes it's all 10, sometimes it's only 5. It just depends on where you guys are. So I'm using a tablet, FYI. Sometimes my tablet goes a little nuts. It does some weird things sometimes. I'm like, oh, what did I do? And I can't even make it happen again. So just bear with me in case that happens. Sometimes when it goes real crazy, I may or may not have 2 videos for the day for notes. We'll see, because I did not pay for editing rights. So it is what it is. All right, so the first thing we're going to do, let me just make sure my tablet's working, and it is. All right, so one of the most basic things, actually, I'm going to stop this camera. Sorry, I know I don't want my camera on. Don't want my camera on. All right, I'm going to shut that down too. I don't need that. All right. So one of the very first things you're going to learn to do in geometry is to name things. It's really important how you name things. Order matters. Letters of the order of letters often matters. And how you write things definitely matters. So in this case, we're talking about segments, rays, and lines. So you have to know the difference, okay? A segment is a piece of a line. So a segment is, if we were talking about just showing the segment, okay, this would be a segment, AB. Okay, let's just say AB, okay? Segment is a piece of a line. You could imagine that there was like more of a line here, more of a line here, but we just took this piece of this line. So this is called a segment. To name a segment, you list the letters and then you put a segment on top of them. That is literally how it goes. Now, this could be called AB or it could be called BA. It doesn't matter, okay? What matters is that you have the 2 letters that mark the end points, okay? These are called end points. All right, so moving on, you have segment and then you have array. Array has an endpoint and it goes on to infinity. So it has a starting point. So if this is A, okay, what we typically have is another point on the ray, B. And the way we write ray AB is we put AB, sorry, see, I'm not actually, oh, okay, there we go. And then we draw a ray on top of it because that's what it is. Now, this is not BA. Oops, sorry, hang on. This is not BA because we are not starting at B and going on to infinity over A. So that is not BA. Rays are more specific, okay, versus a line. If you had a line, okay, and you have PQ, okay, you need to name 2 points because 2 points defines a line. Actually, the definition of a line is basically the shortest distance between 2 points. But basically, a line is defined by 2 points. You must have 2 points, okay? You can't have 1 point because that's not a line. You have to have 2, all right? So the name of this line is either PQ, and guess what we put on top of it? A line with 2 arrows, because it goes on to infinity in this direction and infinity in that direction. Okay, we could call this PQ, or we could call it QP. Okay, either way, that's the name of this line. So take a look here. It says classify each figure. I always, by the way, if you're ever doing directions and you're trying to figure out what they're asking for, it's often really helpful to circle the verb and point to the direct object or underline it. So classify what? Each figure as a line, ray, or line segment. then show how to write it. Okay? You're going to show how to write it. All right, so this is array because it has an endpoint, and we write it by putting HG with a little ray on top of it. Okay, this one is a line because it goes on to infinity on both sides, and you would call it JK with a line or KJ. Okay, I think they'll typically go in alphabetical order, so JK would be more common. And this one is a segment because it's just a piece of a line, and it's LM with a little line on it. Okay, simple enough, moving on. All right, so let me move this. Move up, honey. Okay, so it says analyzing relationships between points, lines, and planes. Basically, this is about identifying a 3D picture that's drawn in a 2D space. You know, so we're always trying to mimic 3 dimensions in 2 dimensions. And this is one of the ways we do it. So you can see like this part here is a plane. And this is like a pencil coming through a paper. This is a line coming through the plane at point R. Okay, so this line is in the plane because it's in the same direction. You can just see that it's in that plane itself. Okay, so what you need to do is be able to understand how to represent these. Now, I'm not there in class. I'm not going to have, this may or may not be an exit question, but here's how you want to take notes on this section. It'd be really nice for you to draw this. Okay. The way you draw a plane is you draw a parallelogram. Okay. The idea is that these 2 lines are parallel. Okay. You can name a plane, but a plane needs to be named either by, look down here. Notice that's not a point. See how they just have a P there? That means that this is called plane P. Okay. Because it's not a point. But you either can name it with a letter like this, or you can name it with 3 points. So this part here, there's a point R that a line is coming through. Okay, it's in the front of the plane, so we draw a solid line. Here's S. But to show that it's going behind, we do a dashed line and then continue the line here. And that's Q. So you can see, sorry, it's not exactly straight. Okay, the dashed line shows that it's behind. So you get the concept that it's coming through. Okay, then to show a line on there, you could just draw a line in the plane. Okay, this line happens to have 3 points, X, Y, and Z. Okay, I think I've got everything. All right, so let's take a look at it. It says in the figure below. Oh, by the way, this happens in tests a lot too, and in texts. They're really just telling you what the picture says. All of this writing, okay, is telling you what the picture says. You're looking for verbs to tell you what to do. Ow, my cat just scratched me. Okay, in the figure below, it says points, blah, blah, blah. Who cares? They lie in the plane. Okay, we can see that they lie in there. Oh, wait, I forgot T. T. Okay, points Q and S do not lie in plane P. You can see that. See, all of this is obvious, but here's the directions for each part below. What's the verb? Fill in the blanks to write a true statement. Get it? It says, suppose QT is drawn on the figure. Line QT is drawn on the figure. Then line QT and are distinct lines that intersect. What line intersects QT? So it's saying draw QT. So let's draw QT. Okay, I could draw it in mine. I'm going to draw it in a different red, just so that mine looks probably not as pretty as theirs, kind of like yours is going to look on your paper. Okay, so I'm drawing QT, line QT. It means connect those 2 points. Okay, I should go dashed right here. And then out, boom. Oh man, that is so bad. Sorry about that. Let's try that again. Okay, so now I drew QT. Okay, it says, suppose line QT is drawn on the figure. Then QT and BLUNC are distinct lines that intersect. So what line intersects with QT? It's either QR or QS. Interesting enough, you could call this blue line, this is the one that intersects with it right here. I'll make it green. You can see that it's intersecting at point Q. Okay, so you can either name that QR, or you can name it RS or QS. And then you literally could also reverse all of these letters. Okay, QS, RQ, SR. Okay, as long as you're naming 2 points on the line, you should be good. Another name for plane P is name 3 points in the plane. That's all you need to do. 3 non-collinear points, actually. They shouldn't be collinear. They shouldn't be on the same line. Don't call them X, Y, and Z, because X, Y, and Z could also be a line. Okay, so you want to get non-collinear points. Okay, so you could call this plane TRX. Okay, TRX. That's for this one. Okay, you could call it plane TRX. And by the way, we illustrate plane like that. Plane TRX, you could call it plane YRT. Get it? You name 3 points. Now, I don't know if they're going to make you put them in alphabetical order. If they did, that would be RTX, right? The main thing is that you're defining it by 3 points. And this one is by RTY. Okay? RTZ, whatever. Okay? Get the idea? 3 points that are not collinear. C, blank and X are distinct points that are collinear. Okay? So what is collinear with X? X and Y, X and Z. They're on the same line. Okay? Interesting enough, I wonder if they would just accept XR. If I had the student version, I'd sit there and play with it. Because look, X is collinear with any point on this plane. You could literally draw a line from X to any point. So I wonder, okay, maybe put XR because they're both on the plane, right? So you could draw a line XR that could be collinear, but I would probably use these guys because they're on the same line already drawn. So I'd probably put X and Y or Z and Y. Okay? Z and X, whatever. This is either at Y or Z is what I'm trying to say. Either Y or Z. Okay? Y, blank, blank, and blank are distinct points that are coplanar. Well, what are on the points? You just name 4 points that are on the plane, including Y. So you could put Y, R, T, and X. Get it? You could put Y, R, T, and Z, whatever. As long as you put 4 points that are on the plane. Okay, you're going to have a lot of openings here. Next. Which parts in the figure below are congruent? I highly recommend you just count the boxes. This is one that a lot of people hadn't done yet. So for this circle, I would look for diameter. Okay, congruent. Oh, I guess the most important thing is the word congruent. You guys, guess what? Congruent is going to become your favorite friend. Okay, that word congruent. It means the same size. It means that we don't have to measure, meaning don't give the measurements. We're not talking about the measurements. We're not talking about what it is, like how big it is or exactly how big it is. What we're saying is that it's the same size. So these are obviously not congruent. These are obviously not congruent. These are obviously not congruent. And these are congruent because look, if we look at the diameter here, let's count it. It's 1, 2, 3, 4. 1, 2, 3, 4. Yep, diameter is the same. Okay, so this is the only one that's yes. Definitely trust your brain and your eyesight. Your brain is very good at determining it, typically. All right, parallel and perpendicular lines. Okay, parallel lines never meet. Okay, perpendicular lines meet in a right angle. If you don't know that, this is perpendicular, right angle, perpendicular. That is the word. Perpendicular. Say it to yourself. Perpendicular. So you know it. Parallel lines are these. These are parallel right here. Parallel lines never meet. Okay? So the only thing you need to know is, okay, do they meet at a right angle or do they not? Okay? I don't think they're going to give you anything too difficult to figure out. And I don't think we have to figure out the slopes in this case. Okay? So that's going to happen soon. Gosh, I don't know what is up with my throat. I apologize. All right, so you can see that these guys obviously don't meet at a right angle, nor are they parallel. So they're neither. You can see that if you extend this line, they're not going to meet in a perpendicular angle, and they're not parallel. So they are neither. The only question is this perpendicular. The easiest way to see this is that you can see that the slope, if you go from point to point to point, you can see you actually literally make a box. The official way to do this is with a slope. And perpendicular lines, if one line has a slope of A over B, the perpendicular line has a slope of negative B over A, the negative reciprocal. So if you look here to get from one point to the next, it's even, you have to imagine that there's like an X and a Y axis here. Whoa, I'm sorry, that is really goofy Y axis. How do I draw Y? Let's try that again. Okay, imagine that there's a Y and an X axis here. To go from one, here you'd go up one, over one, right? To get from one point to there. So the slope of this line is 1. The slope of this one is up 1, over 1 to the left. Sorry, that's negative 1. M equals negative 1. Okay. By the way, these two are actually the hardest ones for kids to do. If one slope is, wow, sometimes I hate my tablet. Okay, 1 over 1. If the slope is 1, it's 1 over 1. The perpendicular line to it would have a slope, flip it, and do the negative reciprocal. Negative 1 over 1. For some reason, this is the hardest one. Most kids do it really easily when it's like this, like 1/2. Say the slope here is 1/2. And then I'm like, oh, what's the slope of the perpendicular line? And that would be up 2 over 1. That would be, gosh, hang on, this is so hard. Hang on. One thing about the tablet, it's a little hard to do because I don't have reference points. So here we go. I'm trying. Okay. People are like, oh, I understand that. That's negative 2 over 1, right? It's much easier to flip a fraction when it has distinct numbers that you understand. This one, for some reason, is the hardest because 1 over 1 is 1 and negative 1 over 1 is negative 1. But anyway, these two lines are perpendicular. You can actually just judge it by eyesight. But I did want to show you that the perpendicular lines, just reminding you, they have negative reciprocal is the slope of each other. All right, I don't get the pop-down menus here. Okay, so right here on this one, I assume in the explanation, they're going to have definitions with their explanations, okay? I suggest you start making a glossary if you need. If you need to start glossary, oh my God, I spelled that wrong. Let's try that again. Glossary. Hello. Okay. So a figure formed by two rays that have the same endpoint. Okay, so they're going to give you definitions. Here are two rays that have the same endpoint. Okay, I am going to call this B. I'm going to call this C, and I'll call this D. Okay, these are two rays. This is ray BC and ray BD. They both have the same endpoint B. What this is an angle. An angle is formed by two rays that have the same endpoint, okay? I'm assuming it's going to be in the definition, but if not, there it is, okay? Copy this down. This is an angle. A part of a line consisting of two endpoints and all the points in between them. So when you're trying to figure out a definition, you start with what they gave you. A part of a line consisting of two endpoints. So here we go. We're going to put two endpoints. Let's call this F and G. And all the points between them. Let's color it. Those are all the points. Therefore, that is a segment. Line segment. Line segment. Okay. Next one. Lines that belong to the same plane that never intersect. Well, here's a good word for you. Co. Think of like co-pilot, co-president, co-whatever. It means together. So co-linear. No, coplanar. Sorry, coplanar. My bad. If they're on the same plane, it says same plane and never intersect. Oh, no. These are parallel lines. Sorry. In my brain, I was thinking it was going to give you something else. Okay, I should actually start this the way I told you. Let's draw it. It says lines that belong to the same plane. So let's draw a plane. And then draw two lines that never intersect. And the only, that's not very good, is it? Okay, I'll try again. These two lines never intersect. Therefore, they are parallel. Okay. The set of all points in a plane that lie the same distance from a single point in the plane. Now, that sounds kind of crazy, but let's start drawing it. Okay. The set of all points in a plane, which we can use the paper as our plane, you guys. This whatever whiteboard is a plane because it's only 2D. Okay, that lie the same distance from a single point. Well, here's a point. And if I start marking points that are equidistant from that point, guess what I make? I make a circle. And that is the definition of circle. So what I'm going to suggest is with these, with the term, is that you go and you look at the explanation and you grab the definitions. I did create a Quizlet on this last year. I might look this up so that you guys have a little Quizlet to go through. But I feel like Alex might be okay for this. Just make sure you look at those because you'll be able to use them. Okay. I will allow you to use your notes on tests, you guys, because geometry is a weird math in the way that it builds on definitions and proofs and stuff. And you're going to need your notes. So you are welcome to keep really good notes from Alex on your geometry. Highly, highly recommend. The kids who had the easiest time last year were the kids who kept notes and took notes from Alex, okay? Anyway, and you can use them on your tests. All right, it says, this is the beginning to segment addition. Okay, that means we're adding segments. It really is as simple as it seems. I think when people make it harder, that's when it gets weirdly hard, and it's not. Okay, it's telling you FG. By the way, notice, they didn't put this on the top of it. And that's because there's an equal sign. Okay, it's going to get a little screwy and it's going to get a little crazy. When we use the word congruent, which means the same size, we use this. This goes with the word congruent. And then, oh my God, my stupid kitty is tearing up my papers. This goes with the equal sign. Okay, and what it means is the measurement of. Okay, it means there's actually a measurement because look, there's an equal sign. So we're giving you the measurement. We're not talking about same size. We're talking about actual measurements. Okay, so I like to do this. I like to do this to get a visual on this. There's a 19 and GH equals 18. Find FH. Okay. This seems pretty simple. It can get a little tough when you start like subtracting stuff. So here's what I want you to imagine yourself doing. Put yourself in here and imagine that you're starting at F and you have to walk. So here you've walked 19. And then you got to still keep walking. Now you walked 18 more. So it's obvious that to find FH, okay, this is the segment addition equation. If they might ask you later for that, it's FG plus GH, see? FG, GH, H. Okay, and then look, what is FG? 19. What is GH? 18 equals FH. This is where your algebra skills and those formula kind of stuff and keeping neat really helps. Yes, you can just write the answer, okay, if you get it, yes. But this is going to help you understand when things get tougher. Okay, so next. Computing distance, this is the last one for today, between decimals. I think they're just getting you used to doing decimals. When I see decimals, I always think money. It's the easiest thing. We are so good at money, and then we get to decimals, and we're like, bleh. No, think money. Here we go. It says find x, y, and yz. So they want us to find how far did we walk here, x, y, and how far did we walk here, okay? In this case, you could put yourself in the situation and walk, and you can see that you walked 19 there plus 9.3, and you're going to get 28.3. Okay, that's, you added them together because you've walked that total distance. For here, you've walked from 9.3 to 16.6. So you got to figure out the distance. To figure out the distance between something, you use subtraction typically. Okay, I didn't use it on that one because it's kind of easier to just think of it, but I'll show you how to use it. So we're going to go 16.6 minus 9.3. Okay, make sure that you put the larger number on the top, and you will get 7.3. Okay, that's the distance. It's also an absolute value, by the way. It's the absolute value of the subtraction. So we're talking about how far you went. You cannot go a negative, okay? The distance is always positive. I should put distance is always positive. So what if I had wanted to use subtraction here? Okay, what I would do is I would take, okay, what are we going to do? It's 9.3. You take the larger number, you subtract the smaller number, and then you get, this turns into a plus, and you will get 28.3. Okay, same thing. All right, yeah, that's all I wanted to say about this, and I'm pretty sure that's the end. Oh no, wait a minute. Okay, for some reason I thought it was and it isn't. Hang on a second. Okay, here we go. Finding a point on a number line given the length of a segment and another point. Okay, this one, yeah. I don't know why I forgot about this one. This one might be your exit ticket, okay? Because this is the one that I answered most questions on last year as far as this section, okay? So here's what I would recommend. Draw the situation to understand it. Okay, so it says, suppose E and F are points on the number line. Okay, so we just have the typical number line here. Here's 0. Okay, and we're saying E, F are somewhere on here, but we don't know where, so we can't put them down yet, guys. It says if EF equals 10. So remember, that is the distance. The distance is equal to 10. Okay, and E lies at -3. Sorry. Now they're telling us where E lies, but they're only giving us E. Okay, kitty. Okay. They're only giving us -3. So this is E, and it's at -3. It says, where could F be located? Okay, if there is more than one location, separate them with commas. Okay, so basically we're saying, where would I land if I was just a distance 10 from -3? So you would count 10 in each direction, because remember, distance is positive. It doesn't matter. Think of this as directional. This is the negative direction, this is positive direction, but the distance is still 10. So we can go 10 in the positive direction. That's 1, 2, 3. Then 1, 2, 3, 4, 5, 6, 7. That's 10. We end up at 7. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And we end up at 7. I mean, yeah. So that's the first one, comma. But we could also go in the negative direction, 10. So you could go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now, if you put that, that would be -4, -5, -6, 7, -8, -9, -10, -11, 12, -13. Okay, so you'd end up at -13. Now, could you do this with subtraction? Absolutely. You could go -3, right? Plus 10 in the right direction. That's saying I'm going to go 10 in the positive direction, and I end up at 7. I could go -3, and now I'm going to go, shoot, here. Sorry. Okay, let me do this. Delete. Okay, I'm going to go in the negative direction now. I'm going to add -10. Okay, so in the negative direction, that's all that means. Okay, 10 in the negative direction. And I would get -13. So can you do it arithmetically? Yes. Can you do it on the number line? Yes. Do I care which way you do it? No. I care that you understand it. Okay. Next. Sorry about this one. I cannot move this guy. I don't know why it doesn't want to move. And I normally can select objects and it's not letting me. Like, look. It's just, okay, if I do this, I just want to show you that it doesn't work. Normally it makes it an object and I can move it. And for some reason, when I created this, it wouldn't do it. So I don't know what the deal is. Okay, it wants you to find the midpoint. If you look on ALEKS, they give you 3 different ways that you could do this. Okay, the first way is to count. Literally, if you want to find the midpoint of here, you could literally count 1, 2, 3, like, and then count from the other side, 1, 2, 3, 4, 4. Like you count the same until you hit the middle. So obviously the middle is -2. That's good for ones that are easy, but man, you want to do it for some things. So you want to have a method, okay? In my opinion, the easiest way to do it is the midpoint formula. You can look for other methods in ALEKS if you would like. The midpoint formula says to take the difference, because the distance, you take the difference. And since we're looking at midpoint, we're dividing it into 2 equal pieces. So you take the difference and you divide it into 2 equal pieces. And this tells you, okay, where it is. So for example, okay, I'm going to take 2 and I'm going to subtract -6. Okay. 2 minus -6 is 8. 8 divided by 2 is 4. This tells you the number of spaces to count in. Actually, you add. This is one of the things this is one of those things in my math that I always have to watch out for. I'm so tempted to take the difference because that is the distance and then divide it. That gives, okay, actually, wait. Don't let me do this. Shh. The difference gives you the number of spaces to count. So in other words, look, this isn't really the midpoint formula, so I guess I shouldn't do that. This is a different way of looking at it. The difference is 2 minus -6 divided by 2. And you're going to get 8, because that becomes positive, yeah, over 2, which is 4. And it's telling you to count 4. So look, I count 4, 1, 2, 3, 4, and I end up at -2. Okay, This is going to be really helpful when you have to divide it into other like lengths of pieces. But for right now, I'm going to give you a different way. That's the actual midpoint formula. Okay. And that is the opposite. You add and divide by 2. And that actually gives you the point. So check it out. You go 2 plus -6 divided by 2 is -4 over 2, which is -2. And that's the location. Okay, this gives you the location. This gives you the number of spaces to count. This will be helpful, honestly, because they will be, eventually they're going to be like divided into 5 pieces. So you want to take the difference, divide it by 5, and figure out how big each segment is. All right. So there's 2 ways. There's another way that they give you. I gave you 3. You count, take the difference, divide by 2. That gives you the spaces to count. So you start at an end point and count in towards the middle. And then the midpoint formula is where you add them and divide by 2. Okay. I think that's it. That's it. Okay. These are good. These are your notes for the day. Okay. So I will typically end the notes. And then here's what you do. You want to write them down. You want to take a picture, and then you want to add them to the classroom assignment. All right.